So it's good to see everyone here. I am Lucas, of course. Thank you for the lovely introduction, and thank you to everyone that I've talked to so far in the last 2 days who have kind of given me ideas and insights on something that is relatively new to myself and to, I think, the OpenSearch and the natural language processing community as a whole in regards to its implementation. So just a little bit about myself first. My name is Lucas. I'm a junior machine learning engineer at Eliatra. I've been there for the last 2 months, and I was previously a robotic process automation engineer before I started this job. And I'm here to talk to you a little bit about what conversational search is. So conversational search is a technique that allows you to kind of leverage the power of natural language processing and generative AI to parse through your data at a scale that is a little more efficient for statistics-based machines like GenAI and prediction models. Because humans as a whole, we tend to kind of suck at large-scale data analysis. And things like these models allow us to very efficiently work through that in a good way. So conversational search allows you to take chunks of your data to pass them on into what is essentially like a meta prompt to a generative AI or a model, and allows you to refine your answers by asking follow-up questions regarding your data. And it happens in a very natural way, almost like you're speaking to a person that may sometimes give you the incorrect data, if it's a hallucination. That happens every now and then. But it allows you to very naturally parse through data rather than a non-technical way. So it's kind of a non-technical response and a technical response, or query and then response. So what makes conversational search work? There's 2 big elements to it. One is the conversation history, which is a thing that is kind of plugged into OpenSearch already. And it is an index or a plugin that allows an LLM to remember aspects of the conversations that you've had with it through time. Meaning that you can start a memory ID with an LLM that you've connected along the pipeline, ask it questions, and then later on, maybe you shut down or you bring your data back up, it will remember the context of the conversation and follow along and allow you to follow up with that data. It learns as you learn, and it avoids repetitions or outputs as a result. And the next real cool thing is the retrieval augmented generation pipeline, the RAG search pipeline. It allows you to facilitate the massive corpus of existing data in LLMs with your own up-to-date concrete data, meaning that many of the LLMs and chatbots that we see nowadays, they have a cutoff date for the information that they are aware of. And sometimes they're trained on so much data that it doesn't know really what to pick apart when it's trying to respond to you. RAG allows you to take chunks of your data, embed it into a prompt to a chatbot or an LLM, and run it up to date almost in terms of the information and the inference that you want. As a result of that, also, it will reduce hallucinations overall in your responses, because it knows exactly where the data it's supposed to be taking its data from comes from, which is from you and your pipeline, and then supplements that data with its additional knowledge, the concrete kind of corpus that has already been trained on. So setting up conversational search, I'm just going to kind of follow the documentation almost that is available on OpenSearch and what the requirements for setting up a conversational search pipeline in one of your indexes is. And what you'll need is a machine learning configured node. It doesn't need to be specifically a node for the purpose of machine learning. It can be any node as long as the proper features and plugins are enabled. And those are the ML Commons plugin, the memory feature, and the RAG pipeline feature, as you can see here on the right. What you'll need after that is a chat agent API access key or an endpoint if you're trying to run the thing locally. And that will allow you to build a thing called a connector, which we'll get into after this. The connector will essentially act as the bridge between your data and whatever model you're using for inference. And then finally, of course, you'll need an index, a database, somewhere where you're storing your data, and somewhere where you will retrieve that data to send into a chatbot or an LLM for inference. So moving on, you've got to create your connector. This is the first big step in this process, but what is a connector? As I said before, it is a piece of code that allows you to connect to an external third-party platform, machine learning platform in this context, and acts as that bridge between your cluster and the LLM used for inference. This is an example of kind of the code that gets used for it. You are calling the plugin, the connector, you're giving it a name, a description, the protocol, the parameters. Temperature is one interesting up there for people that don't know maybe so much. Temperature is the rate of creativity sometimes that you can allow a chatbot or an LLM to have in regards to its responses. The higher you turn up the temperature, the more creative, and sometimes the word we use is wrong, the answer it'll have in regards to that. But if you want something to be cold, static, logical, generally just keep the temperature to 0. After that, you got your credentials, your OpenAI key, or whatever we're using. You could use Claude. There's a number of whitelisted kind of, I say whitelisted, it's because they're in the documentation and they provide the blueprints for these connectors in their documentation that you can use. And then the actions. So this will be predict. So we're using a prediction style model. It's trying to infer context from the words. It's trying to give you back an answer that you think you want. So we're doing predict. We're doing the endpoint of the model that we're using in this example, ChatGPT, and passing in our key and the request body, which overall is just kind of the payload that gets sent to this model. After that, two very simple things. You will get a connector ID from running this piece of code, which will be used to deploy and then register your model. So registering is very easy. Once again, you give it a name, give it the function name, which is remote in this case, because it is a model that is existing outside of OpenSearch. It's living somewhere else, so it is a kind of a remote function of registration. You give it a description, and then finally the connector ID that you acquired from the previous run of the command. After that, you deploy the model. You use the model ID that you acquired from your registration, you deploy it, and then it'll be connected to your OpenSearch cluster, which you can see here. This is an example of what the machine learning model dashboard looks like in OpenSearch dashboards. It allows you to keep track of what models you have uploaded, you could be, or connected to even. You could have text embedding models. You could have sparse vector embedding models. You could have conversational agents. All of this lives right here in the machine learning dashboard. It tells you what the source is, whether you uploaded it locally, you connected it to it remotely, the name of the connector, the ID, and then ultimately whether that model is connected or disconnected at the moment. So you can do any troubleshooting. If you're running lots of machine learning processes on your cluster, this page will get very full very quickly, so it's good to kind of have an idea of how you can navigate that. Now, let's get on to the RAG search pipeline. So as I said before, RAG is this pipeline, this search pipeline that's going to allow you to take certain elements of your data and send it into this payload to be sent to a model for inference. The first thing you're going to want to do is connect that model that you registered there in the previous steps. After that, you're going to provide in the setup of the RAG search pipeline the context fields to supply to the LLM as contextual data. So what that means is you have a document with a number of properties, and some of those properties you want to send to the LLM as context. This, in the search pipeline, is where you infer or supply those context fields. You then get to set, I don't know if anybody's ever kind of messed around with system prompts or trying to fine-tune maybe an LLM at the hyperparameter level, but things like you can set the system prompt and the user instructions for your chatbot or your model at that point. So things like, you're a helpful assistant, or I want you to only give me a response in less than 100 words. That is all configured at the RAG search pipeline stage. So this is an example, once again, of the code, what it looks like. You put the description, you put the tag, you put the model ID that you registered before into it, and in blue highlighted, this is the context field list. So for the sake of this example, we went very simple. We just provided one property that is text, that contains text. And any document that you then pass into this search will find the document, find the text property, take the content from that property, and supply it to the prompt for inference. System prompt, once again, you're helpful, thank you. User instructions, you want your answers to be informative and concise and less than 100 words. Why might we want that to be less or around 100 words? There's two big considerations. One is a thing called context windows, which is an LLM works on a system kind of based around tokens, which are just fragments of words. Sometimes it can get too big, and it loses the run itself, the run of itself. Sometimes it has just too much data to play with. You're sending it too much, and it just kind of gets jumbled up and doesn't know what it's talking about anymore. So sometimes less is more in regards to getting an answer from an LLM in these regards. And the next is cost, but we'll talk about that in a minute. So after that, we're just going to kind of do a quick fire run of setting up the additional parameters. We need to, of course, create our index, which I've labeled on the right. As I said, a very simple one. We're calling it my RAG test data. We're setting the default pipeline to be that RAG pipeline that we created in the previous step. And we are putting a property, text, type, text. After that, we ingest our data, and we create what is called a conversation memory. So a conversation memory is an index that lives within this ML kind of plugins system. And every you initialize it, you give it a name, and it'll give you an ID. And that ID you then input into the search pipeline step at the very end. And this is how the LLM will remember the conversation that you're having with it through time. And you can also use that to look up previous conversations, previous messages, and what previous data has been sent to the model to get to the point where it is now. So here's just an example, simple again, of how we utilize once it's all set up. So we're just going to do a simple search. We're going to do a query match to find a document within our index that has information about the population of New York. Then after that, we're going to fill in the generative parameters, which is when we were creating our connector at the very beginning. This is the information that it's going to be looking for. We can reconfigure the model name. Maybe we don't want to use GPT 3.5. We want to use GPT 4. That can also be changed at that level as well. And the question that we will be sending to the LLM, as well as the chunks of data that we get from our RAG pipeline. The memory ID, once again, will be used for reference, and then the context size and the message size dictates the context window, the max amount of tokens, minimum or maximum, the amount of documents that we could send. Because in this example, we're only finding one document, and we're only sending one document. But there might be some cases where you get 10 hits, 50 hits, 100 hits, 1,000 hits, and it can't be feasible really to send that many documents and that much context to an LLM. It's not going to know what to do. This is once again back to the max context window that I was speaking about. So there you can maybe try to filter based on max score. You can have it send the 5 most relevant documents from your search into the LLM and try to constrain those potential issues. On the right, we have our output. So as we said, we found one document that matched population of New York in 2023. And at the very bottom, highlighted, is the response from the LLM. So we sent it data from our document. We sent it a question. And from that, it was able to infer new and additional data. Now, to kind of look a little deeper into how this works, this is what the result of looking up one of the messages, the memory IDs, from a different search that I did for a different demo. It was a kind of a pub bar stock reporting system where we input data, products, the product names, the amount sold, the price of that product, and then we try to infer context or analysis from that data that we input. As you can see from the prompt template, it's building everything that we had asked it before: the system prompt, the user prompt, the response from the LLM, and then at the very bottom, the metadata is the data that we have passed in from our documents into the LLM as a metadata, as additional data for it to infer upon. It wouldn't have ever been able to tell me how many products a random bar that I was asking about could have done without this data. But now that I added it in, it was able to infer that all by itself. And then for that, I can go deeper. I can continue to ask questions. I can say, based on this day or that day, if I'm doing a multiple day update, what was the worst selling product? What was the percentage difference between two products? And it allows somebody maybe not from a technical background to infer, do analysis that would normally take somebody with a little more data analysis background. And it opens up the exciting realm of generative AI, models, statistics to people who normally wouldn't have that opportunity. So here's some additions. We're coming to the end of it slightly. Additions and considerations regarding the current infrastructure for conversational search on OpenSearch. Does anybody want to take a guess at what this number means? Yes. It is absolutely the cost. Yes. So for every 1,000 tokens that you send to OpenAI's ChatGPT, that is 0.002 cents per API call. For me, that is nothing because I'm working on a small local database and I'm doing just tests on it, but scale that up. Scale that to you have hundreds, thousands, millions of documents with teams of people trying to infer and do analysis based on using LLMs, that cost is going to rack up pretty quickly. And, there are potentially solutions to that. One that I currently like the idea of is this recent surge in open source, locally hosted LLMs and models, things like Llama 3, things like Mistral, things that you can run entirely locally on your own machine, run on a server, build a connector to your database, and have that come at no cost whatsoever to the user. You can also say goodbye to one of the biggest barriers to businesses and individuals looking to use LLMs, generative AI, all these sort of things in their businesses, and these are privacy issues. A lot of the times when you're sending your data out to these things, they are being whisked away into the void, and they're probably being used for some training data somewhere, and you're going to get into very big trouble if your code base ends up on someone else's computer later on down the line. So things like a locally hosted LLM that can have the same inference capabilities as some of the big models such as Claude or OpenAI, the ability to connect your database to get that same level of analysis is huge. And it just requires a little bit of tinkering, a little bit of work, a little bit of knowledge of how these connectors work. And once I figure it out, I'll be super happy to ask anybody who knows maybe more about it, because I certainly would love to make it work. And finally, I'd like to look into maybe refining the search capabilities. The examples that I gave you before, they were lexical searches. They were just very classic search measures where I searched for a keyword within my document and it was retrieved to me. But once again, scale that up. What if we could, at ingest time, do some vector embedding, some neural embedding, and retrieve our documents and do almost like a multi-stage RAG pipeline, where we use a form of neural search to retrieve the most relevant documents. Maybe we're not working with basic data, maybe we're working with images or text, and that way further on down the line, we want to send it into an LLM or a Gen AI to infer additional context or data. That's a super exciting thing. It's not something that I've seen myself already, something I'd love to see implemented, and if anybody has any thoughts about it, I'd love to hear those too. But yeah, this is just one last little thing before I go. I have built, over the last couple of days, I built a little demo using conversational search. And it was the example that I used before of the stock, the bar stock system. My best friend runs a bar. He has all this data. He's always looking to see, OK, can we figure out more things about it? Like, what could I do if I send it in? And I said, let's try it. Let's build it. And at the very simplest, at the simplest endpoint, what it is it allows us to upload our documents, our products, our prices, how much we sold, and on what day. Then we do a simple date range lookup, retrieve X amount of documents, and ask the LLM, in this case OpenAI's ChatGPT, a prompt on the data that I'm passing into it. How much Guinness did I sell? It tells me that I sold 231 pints of Guinness on the first and 578 on the second. Now, that could be, once again, expanded upon. He wanted to ask, how much alcohol do I waste every night? Did I have an event on that night? Who was working? Then we were getting into kind of like the more ethical, dubious nature of it. I didn't really want to, that's where I kind of put a hard stop to it. But it already shows a really interesting use case, and he loves it. He's really interested in how this could be applied. He's, whenever he's been given maybe the current stock system that he uses, he has to pour through like an Excel sheet. He has maybe reams and reams of data that he's looking through, and sometimes it can get very boring. Sometimes you might miss stuff. But the ability to inject a model into this to be an assistant in analyzing your data for a non-technical person, the applications are huge. Right now, things like models and machine learning, it's opening up to the public massively. We see ChatGPT increasing in uptake every single week, every single month. But for businesses, they're slow on the uptake, and there's privacy issues, it's cost issues. But opening the door to them through the use of things like RAG pipelines and OpenSearch as a vector database or as a storage for these things could really open the door for a lot of people hungry to utilize this technology. So this is, once again, just the example of building the RAG pipeline for this particular demo. So instead of our context fields being just text, we pass in a number of parameters from the documents inside. It was the products in question, which were all nested objects that then included price and amount sold and additional data like that, and then at the very end, just the day that it was on. And then we edited our system prompt to make sure that it was a helpful assistant for stock reporting. It didn't need to infer any additional context. It just needed to look at the data and give me what I needed back, and that was it. But yeah, that's all. Thank you so much for listening to me. I hope it was interesting and you learned some interesting things, or maybe have ideas of how the technology could be utilized at a scale or implemented. But yeah, thanks.
Thank you. Thank you for your interesting talk. And yeah, now we know about how we can implement with OpenSearch. So does somebody has any questions? Yeah, you're first. Let me give you microphone.
Thanks for a very nice talk. I was intrigued by what you mentioned about the conversational memory being a separate index. So my question is, how does that work when you have like many users, and how are the different conversations managed there?
Unfortunately, I would love to answer that question at a scale with many users, with many indexes, but the environments that I've tested this in, it has been single node infrastructures with just myself as a user. So I can't speak on how multiple users would be able to access an index like the memory index with the memory ID and retrieve that information. There could be security issues actually even involved with it, with some other user being able to access previous conversations with previous users in that regard. And it's something that would be very interesting to look into. But I can't speak for that technology at the moment, I'm sorry.
Thanks.
Okay, who has another question? Maybe somebody wants right now implement it his environment. Yeah.
Hi, quick question about the output of the when you send the message to get a response. So I saw that you had this additional metadata, but I think this is the input. But my question is, can you get, for example, the evidence that the response is based on as a JSON object?
Sorry, could you repeat the question?
If you can get, for example, a JSON object out of the response that might contain, for example, I use document 1, document 2, and so on, or do you only get like a response as a full text?
You will get the response. So from testing it in OpenSearch dashboards and through this system, I have only ever actually received, I've seen no indication of a response in JSON. When I have tried to build similar systems using Llama 3, not using OpenSearch as a database store, I have seen responses in JSON tokenized. So it could be something on the OpenAI end that responses via the API are given in full text, whereas in some it might not be as refined, we'll say. But in my experience utilizing this, I have always received from these responses and from down here, it has always been in a full text return. Now, interestingly, now that I think about it, in the user prompt, you could very well, and this is where you can kind of set these parameters for how and in what way the model responds to you, you could potentially ask it to respond in a JSON text. I've seen that used in some other scenarios. Myself, I haven't implemented them, but I have seen user prompts facilitated in a way that all responses must be in a JSON format, and it works pretty well from what I've seen. But I hope that answers your question. Yeah, thank you.
Yeah, good. Thank you. Thank you for answer. We have another question. It's from Anthony here.
Thank you for the talk. It was very interesting indeed.
Thank you.
So it's more of a scenario based on your presentation, following up with a question, in which hopefully we turn up into an idea. Based on the bar that you've used this, in which you got the responses as to how many liters of Guinness you've basically consumed, the price in which the Guinness was consumed at, in the range of dates in which it was consumed at, whether or not you are allowing your AI to actually provide the price, which is ideal based on the consumption rate on a given date, based on the hour of the day, in which you could automate that, in which you connect the AI back to automation, based on the data you've derived, to go back into OpenSearch to say, this is the ideal price in the bar for the pint of the given brand on a given day, on a given time.
That's a brilliant idea, and I don't think I should give that to my friend because he's definitely going to use that to jack prices up. But that's brilliant. Yeah, no, I like the idea, and it was actually an idea that was floated to me even earlier, about 2 hours ago, was this idea that the context that is received from the LLM or the model that you're using can be inferred onto a next stage of inference in some way. There was a great idea that it was if you asked it to produce a script for plotting some data. And then that data was then taken out and implemented into a model that can actually produce graphs based on scripts, based on data that has been passed along this multi-stage RAG pipeline. The idea, of it being kind of a self-contained, self-updating, self-learning system is it's really, really interesting.
You could even expand it with food. You can even expand it based on the expiration date, in which you can lower down the prices based on the fact that it's not consumed. I think the possibilities are endless based on that.
Yeah, absolutely. I fully agree. Absolutely. It's an exciting prospect. Thank you.